Today in pre-cal we started a new lesson about trigonometry. And trigonometry is used in lots of science fields, including space, mechanics, biology, and a variety of other fields. Basically, we'll get into that more as we get into this unit. But this is what we will be studying for the remainder of the year in pre-cal, so this stuff is very important. There are two types of measures for angles, and those are degrees, which you are very familiar with, or you should be, and radians. This first section we're going to talk about is in degrees, and then we'll focus more on radians here in a minute, and that will be our focus for the rest of the year. Let's talk about some terms, starting with this line right here is called the initial side. And it's called the initial side because that's where we start, and then the angle I form is this space in between. And this side where it ends is called the terminal side. Okay, if we look at a coordinate plane, I'm going to draw this out to the side. We know that our quadrants are 1, 2, 3, and 4, and we've known that for a while. Right here in quadrant 1 would be the positive quadrant, and so that would start at 0 degrees. If I went this way, up here at the y-axis, this would be 90 degrees. Another 90 would be 180 degrees. Another 90 would be 270 degrees. And the full circle would be 360 degrees. And the way that I'm going here is in the positive direction, and that is counterclockwise. Okay, now let's look in the negative direction. So I'm going to draw another coordinate plane. I'm going to start at 0. I'm not going to label it, but my quadrants are still 1, 2, 3, and 4. And if I go in the opposite direction, or the negative clockwise direction, then negative this way would be negative 90 degrees, negative 180 degrees, negative 270 degrees, and negative 360 degrees. Okay, so that would be the negative direction. Now, if I put these two pieces on top of each other, they would mesh, and negative 90 would be the same as 270, just like negative 270 would be the same as positive 90. I'm not going to do that because it might be just confusing to see that much information, but you should know that those things are simultaneously happening. Most of the questions for now surrounding that are going to be, what quadrant is something found in? So, let's look at a few examples, A, B, C, and D. If I'm looking for angles 77 degrees, negative 48 degrees, 181 degrees, and negative 110 degrees. If I'm looking for 77 degrees, that's between 0 and 90, so that's in quadrant 1. If I'm looking for negative 48 degrees, that's between 0 and negative 90, that's in quadrant 4. 181 degrees, I would go the positive, go 180 and 1 more degrees, that would be in quadrant 3. And then negative 110, I would go negative 90 and a little bit more, and that would also be in quadrant 3. And that's all we're going to look at for today for degrees. Now, shifting gears, let's move on to learning about radians. Okay, radians are a unit of measure used for circles, and this is the more common one in calculus, so this is what we'll spend the remainder of the time in pre-cal learning about. If you want to do more research about why we call them radians, what they stand for, that kind of thing, you're welcome to do that. And I put out the offer today that if you'll research it and write me a well-written paper by the end of the 6 weeks, I will replace a warm-up grade with that grade. But you need to do good research if you're interested in doing that, learning more the theory. I'm going to give you more the practicality, the what, instead of the why piece. Okay, if we go from 0 again, this is quadrant 1 still. I go all the way around, 1 full turn, and that is 2 pi radians. Okay, so 1 full turn is 2 pi radians. 2 pi then would be equal to 360 degrees. And that unit of measure is radians. I will not write radians every time, and there's no special symbol like here for degrees, so we'll just leave it alone most of the time. So if 2 pi radians equals 360, then just plain pi would be the same as 180 degrees. We could label that there if we wanted to. Now, if you're wondering what is 1 radian valued at, let's go off to the side here and just look real quickly at 3 little pieces that might help clear that up. Okay, if half a turn around a circle is pi, we just saw why that happens. That's 180 degrees. We know that pi is about 3.14, right? We know that because that's always been pi. We've learned that a long time ago. If I cut that in half, so divide by 2, pi over 2, cut that in half, that's about 1.57. If I want to know how much 1 radian is, then it's somewhere in between here and here. And if this is 1.5, it's about 2/3 of the way up. So right here, mine might be a little bit more towards half, so about there, that's about 1 radian. A full turn around the circle is about 6.28 radians, and we're going to mostly stay within terms of pi, so this is not real central to what we'll be covering, but I just want you to have an idea of what that looks like and where it's coming from. The next thing we want to do is to convert degrees to radians. So for example, I want to convert 135 degrees to radians. And to do that, I'm going to multiply 135 by pi over 180. If you're a practical person and you just want to know what to do, that's what you do every single time, multiply by pi over 180. If you're a y person, the reason that works out is that pi is equal to 180. So if I put pi over 180, that's the same as multiplying by 1. And degrees over degrees will cancel out the degrees and switch me over to radians. To do that, I'm going to do 135 times pi is 135 pi over 180. I want pi to stay in my answer, so my final answer will just be whatever 135 over 180 is reduced. And that is 3/4. So 135 is the same as 3 pi over 4 radians. Okay, the final thing on this front side of our notes is to find the location of 7 pi over 8 without converting to degrees. Okay, so eventually what we want to do is to be given any amount of radians and figure out what quadrant it's in or where about it is without having to convert back and forth. To do that, we need to learn more about how we can separate circles so that we can figure out their radian measure. So onto the back we have 5 circles that I've kind of pre-drawn for us. And we're going to start with that question we just looked at about where would 7 pi over 8 be. And then we're also going to divide the remaining circles into the most common angles. And when I say most common, I mean the ones that we're going to be concerned with the most often. And that would be things of the nature of pi over 2, pi over 3, pi over 4, and pi over 6. Okay? If we were talking about degrees still, this would correspond to things every 90, every 60, every 45, and every 30 degrees. And those are the most common angles. Let's go back to this question about where is 7 pi over 8. I know that 0 is here, pi is here, and 2 pi is all the way around. Now, if I wanted to find where 7 pi over 8 is, I'm going to start with the top half of the circle because that is 1 full pi. Now, if I'm thinking about splitting something up into 8 groups, right, and I want it evenly, I could split it in half first, and half of 8 would be 4. So this part would be 4 pi over 8. Now, if I wanted to get it into halves of that, I could half this and this, and so I'm going to do that with some dotted lines. The reason I'm using dotted is because these are not quadrants, whereas before they were. Okay, and now I have 1, 2, 3, 4 pieces up top, and I only care about the top when I'm dividing. I'm dividing into 8 because that's my denominator, 7 pi over 8. Now, if I wanted to get 8 and I have 4, I could cut those in half again and get to 8. So that's what I'm going to do. Okay, and now I have 1, 2, 3, 4, 5, 6, 7, 8 pieces on top. I can label those. Pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8, and 8 pi over 8. And of course I could always continue on. I'm not going to here because I really only care about 7 pi over 8, which is right here and would be located in quadrant 2. But I do want to show you that we could reduce some of these fractions and see what they're equivalent to. So 2 pi over 8 would be the same as pi over 4. 4 pi over 8 would be the same as pi over 2. 6 pi over 8 would be the same as 3 pi over 4. And 8 pi over 8 is the same as pi. And that's important that that happens. If it didn't, we would have done this wrong. So that's a good way to double check that you're getting it. If I wanted to continue, I could do 9 pi over 8, 10 pi over 8, 11 pi over 8, 12 pi over 8, 13 pi over 8, 14 pi over 8, 15 pi over 8, and 16 pi over 8, which would reduce to 2 pi. And so that would be a good way to check and make sure that I got the right thing. In this case, I did. Now let's take a look at these most common angles and wrap this lesson up. If I wanted to see increments of pi over 2, I would start here at 0 and go to pi. To find pi over 2, I would split the top into 2. That's already done by this quadrant. So we know that this is 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. Where this one reduces to pi, and this one, of course, will reduce to 2 pi. And that's all there is to that one. Let's skip pi over 3. We're going to put that one here, but not yet. Let's go to pi over 4. I have 0 and pi. It's already cut in half. To cut the top into fourths, I would cut the halves in half. So I'm going to do that with my dotted lines. And I would have pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. And of course, I could always reduce my fractions. And I should be noticing by now, guys, that when I reduce my fractions, every time the top is pi over 2. Every time this one's pi. Every time the bottom is 3 pi over 2. And every time this one's 2 pi. That's because eventually we're going to overlap all of these circles and we're going to learn about their measure. I don't want you to be overwhelmed by that. I just want you to see that these are all the same thing. If I did pi over 6, every time I start with 0 and pi, I want to cut it into 6 pieces. So far we have 2. So instead, let's cut each half into thirds. Okay, if I cut each half into thirds, I now have pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and on and on and on. And I'm not going to continue there, again, for the sake of time, and because I think you could do that on your own. And I could reduce some of these up top and see that I'm getting some similar angles again. If I wanted to write, it'd be 7 pi over 6, 8 pi over 6, 9 pi over 6, 10, 11, 12 pi over 6, which reduces to 2 pi. The last circle we need to look at is about the angle pi over 3. The reason I say this one for last is you'll notice that 2, 4, and 6 are all multiples of 2, and so we use this middle line. We would take that it's already cut in half and then go from there. For pi over 3, we're starting with 0 and pi, and we want the top section cut into 3 equal parts. That's very difficult to do with this middle line because that will not create 3 equal parts. So we're going to kind of cancel that out, pretend like it's not there, and divide this into 3 equal parts. So I have 1, 2, 3 pieces, and label those. Pi over 3, 2 pi over 3, 3 pi over 3, which is pi, 4 pi over 3, 5 pi over 3, and 6 pi over 3, which is just 2 pi. And that was it for the lesson today. Tomorrow you'll get the assignment, and if you have questions, we'll go from there.